Hi, my name is Caitlin Mahar, and I'm a lead engineer at MongoDB. Today I'm going to talk a bit about using server-side Swift with MongoDB and Vapor and show you a demo application. To start, let's talk a little bit about why you might want to use Swift on the server. Swift is known for being safe, fast, and expressive. You might think it only runs on Apple platforms, but in fact it runs on Linux as well. Compared to many other popular server languages with automatic memory management, Swift has a small memory footprint and is CPU efficient. Swift applications also start up very quickly, which makes Swift a good fit for cloud services, which are often rescheduled onto new VMs or containers, and for building serverless functions using platforms like AWS Lambda. Swift also has deterministic performance, as it uses automatic reference counting rather than garbage collection, and doesn't use just-in-time or JIT compilation. For more info on all of these aspects of Swift and why Swift is a great fit for server-side development, I'd highly recommend checking out swift.org/server. So now you might be wondering, can I use Swift on the server with MongoDB? The answer is yes, you can. We maintain an official Swift driver that's designed for use in server-side Swift applications. You can find it at the GitHub URL here, github.com/mongodb/mongo-swift-driver. So now that we've talked about Swift, let's talk a little bit about Vapor. Vapor is the most used framework for developing web applications with Swift. Since a lot of MongoDB users are developing web apps, naturally a lot of Swift driver users want to use the driver with Vapor. This led us to build MongoDB Vapor, a library which integrates our driver for server-side Swift with Vapor to make it easy to use the two of them together. Now I'm going to show you a demo of how to get started using that library, which you can find at github.com/mongodb/mongodb-vapor. So the first thing I'm going to do is start up a local MongoDB server on my machine. My application will use this to store data. Next, I'm going to create a new application using Vapor's command line tool, Vapor Toolbox, called My MongoDB Project, using the MongoDB Vapor template. I'm going to select Yes to using Leaf, which is Vapor's library to allow you to create front-end templates. Next, I'm going to move into my project directory, and I'm going to start building my application. This might take a little while. Once that's completed, I'm going to type Swift run in order to actually start my program running. As you can see, my application is now running locally. Let's go check it out in the browser. So this is a basic application that allows you to keep track of a list of kittens and their colors. I'm going to add a couple kittens here, which will store them in the backing MongoDB database we just started. As you can see, the page stays live updated with the list of kittens in the collection. So now I'm going to give you a quick walkthrough of the code behind this application. First, we have our package.swift file, which is how Swift projects declare their dependencies. You'll see in addition to Vapor and Leaf, we also have the MongoDB Vapor library as a dependency here. And we've added MongoDB Vapor as a dependency of both the run and app targets of the application. So moving to run/main.swift, we can see a few lines specific to our MongoDB configuration in here. The first is this call to app.mongodb.configure, which configures a global client for use in our Vapor application. Here we pass in the MongoDB connection string to use. We'll first look for an environment variable named MongoDB URI, and if that's not found, we'll fall back to the default MongoDB host port. Also, in this defer block, we make a couple of MongoDB-related calls. These perform cleanup just as our application is shutting down in order to clean up driver resources, ensure that we properly close all connections to the server, and so on. Moving to the app target, we've got a couple of files. The first is configure.swift. The relevant logic to MongoDB here are these calls to set up our content configuration. Here, what we're saying is that when this application is decoding and encoding JSON data sent via HTTP, to use extended JSON encoder and extended JSON decoder. This is important because extended JSON is a MongoDB specific version of extended JSON that ensures all MongoDB type information is preserved. So we'd like to use these encoders and decoders when we can. Let's move on to app/routes.swift. The first thing to note here is that we've defined a struct called kitten, which corresponds to the structure of the MongoDB documents in our kitten collection. In addition to the name and string properties, our kittens have an underscore ID, which is a BSON object ID, and a created at date. We also define, via an extension to request, an easy way to access the Mongo collection that stores the kittens. So here we access the request client in the home database and the collection kittens, and we pass in the content type that we're using along with our collection, which allows us to directly use that type and not have to think about converting to and from MongoDB documents ourselves. We're then able to use that kitten collection within our request handlers that are defined in this function. So the first of these handles a GET request at the application's base URL, which returns a view. So here we access the kitten collection and call find to retrieve all the kittens. We convert the resulting cursor to an array, and then we pass those kittens to the view renderer, which passes them to our leaf view. And that view takes that data and turns it into that page that you see. We also have a handler for a post request to the application's base URL, which first decodes a new kitten from the requested data and creates an instance of that kitten data type. It adds the created at date so that we can store that in our collection, and then actually calls kitten collection.insert1 to insert the kitten in our database. And finally, I'll give you a quick idea of what the actual index.leaf page looks like, which makes up the single page of the application. So this is a pretty simple page, and it mostly just looks like HTML. The one thing to note is that we have this leaf-specific logic here. We're looping over the kittens that we passed to the leaf view and displaying their name, color, and the date that we created them in the table. So that's just a small example of what you can do with MongoDB along with Vapor, and how you can get started by using our template application. We'd love for you to try out the library and let us know what you think. As I mentioned before, you can find it at github.com/MongoDB-MongoDB Vapor. Thank you so much for watching.